All right, good morning. I apologize for doing this to you 2 days in a row. I actually am in the building today, but I have some cleanup that I have to do for the science prep room, so that's where I'm at today. Um, but I will be back tomorrow. Um, so here's what we're going to do today. I'd like to take notes over accommodation and lens correction. So um, that will just wrap up our optics unit here. A couple things on this homework side that I want to make sure to point out to you. Double check on Power School, the electricity labs. There was a number of people who forgot to turn in. There were 3 labs. There was the um, electric field mapping lab, there was the electrostatic stations, and there was the series and parallel circuits lab. And it was 5 points apiece, and I just entered them as one 15-point grade in there. Double check if you have less than a 15 out of 15, it's because you forgot to turn in one of those. And if you could just get that to me when I'm back tomorrow, there's not going to be a penalty for that, but I do need to make sure to get those. So double check if you have less than a 15 out of 15 on Power School. I have written down on there what it is that you're missing. You should be able to have your syllabus finished by Friday. As a matter of fact, you know everything now. I will have some time tomorrow to take questions over that. But on top of your syllabus, we also have the lens labs that you should have ready on Friday. And you know you got your final exam review packet, which you had time to work on yesterday. You'll also have some time to work on it probably at the end of class today. But don't let that sneak up on you. But especially since you had all day yesterday and all day today, you should be in a pretty good spot with that. I'll be available to answer questions specifically on problems tomorrow, but don't let that sneak up on you. Okay, the first thing I'd like to do today is talk about ray tracing patterns. And so if you look at your notes page that you picked up when you came in, oops, wrong browser. This was what you did in, just give me 1 second here. This is what you did for the lab last week, and I had meant to go over that yesterday, but yesterday I ended up not feeling well enough to come in. So I do want to make sure to explain this, that you saw, right? You did this, but I want to make sure to explain what's happening here. So in particular, I want to notice 3 things, right? I want to notice, when does a converging lens make a real image, when does it make a virtual image, and when is there no image? So back here you can see, when the object's back here, the image over here is a real image. So when the object is outside, the focal point, you get a real image, and it's always an inverted real image. So that's the first thing that you can write down. When the object's outside the focal point, you get a real image. And then when it's inside here, right, we're saying, where's the image? It doesn't look like it exists unless you're over here looking at it and your eyes trace it back and it appears like it's back here. So when you're inside the focal length, it's going to be a virtual image. So real image outside the focal point, virtual image inside the focal point, and when I'm at the focal point, look at what these rays are doing when I'm at the focal point. They're more or less parallel, which means when you're at the focal point, there is no image, right? There can't be an image because these rays are never going to converge either over on this side or if I trace them back to this side. This is why when you did the actual lens lab, this is why you got undefined for the image distance, because there is no place for the rays to converge, so there will be no image. Okay. Now, another thing that I would like to discuss is these principal rays, which are what we draw, right? So these are the 3 rays that we draw when we do ray tracing. You got one that starts parallel to the principal axis, goes through the focal point, one that goes through the focal point parallel to the principal axis, and one goes straight through the optical center of the lens. what I'd like to point out of that is you'll notice you can follow those. You can use those three principal rays even if they don't hit the lens, right? So this animation is drawing them even though the rays aren't hitting the lens. And you might wonder, how can that possibly be, right? How can I use this ray? Like, this ray doesn't go through the lens. Why is it bending there? Well, those aren't really the rays that are going through the lens. And I'm going to click to mini rays here because I think that this shows what's really happening. What's really happening is in this object here, right, you've got rays going out in all directions. And some of those rays are going to hit the lens and are going to be refracted into an object. Now, it's not necessarily the three principal rays are not necessarily the ones that refract, but the lens is shaped in such a way that if I draw my three principal rays, right, they hit at the same spot, even if they don't hit the lens. If I follow the rules for the principal rays, they do the same thing as all the rays are going to do. And so you can use principal rays even when you recognize that, well, they don't actually exist, right? That, sorry, where was that? This ray, in this image, this ray here, right? This doesn't exist. This ray would just keep going straight. There's no lens to make it bend. But why can I still use that? Because whatever rule this is following, all of the rays are following it, and they're still going to cross at the same place if you just follow the rules of the principal rays. So I wanted you to see that because that's sometimes something that you'll see. All right, so that was just some wrap up that I had intended to do yesterday about your labs. Again, I apologize. This is not ideal that I would be gone 2 days in a row. But if you do have questions on this, I will be back tomorrow and Thursday, and you can answer me. You can ask me questions about it tomorrow and Thursday. I'm going to flip videos here because I need to look at a piece of paper now.